Okay, so for 3.12, which is the last section of this unit, we're going to start with parallel and perpendicular activity 1. So each one of these three lines are in slope-intercept form. So graph your lines from slope-intercept form. Use your y-intercept and use your slope. And then you can answer the questions about each one of these three lines. So there's the graph. Graph them all on the same graph. Make sure you make a straight line. Question 2 asks what you notice about the three equations. What do all three equations have in common? And then 4 says complete the following statements. Lines that are parallel have blank slopes. And then that brings us to activity 2. So again, these are in slope-intercept form. So you're going to graph A on the graph to the right, and you're going to graph B on the graph to the right. And then you're going to say what you notice about the graphs of the equations. And then on the next one then, for C, you're going to graph C on the graph to the right, and you're going to graph D on the graph to the right. And then question 4 also asks, what do you notice about the graphs of the equations? 4 says complete the following statement. Slopes of lines that are perpendicular have a product of blank. So if we're talking about two lines like this, y equals 2x plus 5 and y equals 3x minus 2. Well, we're talking about the slopes of the lines, which are 2 and 3. And the word product means multiply. So the product of the slopes of these two lines would be 2 times 3, which would be 6. So these are obviously not perpendicular lines, so that's not going to be your product. You should get the same product for the slope for both of the two perpendicular line graphs. Okay, so that brings us to 3.12, which is parallel and perpendicular lines. So parallel lines are like railroad tracks. So there are two lines that are never, ever, ever going to intersect. So these would be two lines that are parallel. And then perpendicular, perpendicular lines. So if this would be a set of perpendicular lines, the x and y axis. They meet at a 90-degree angle. And each one of the angles is 90, but you can represent that with just one. You can also have two perpendicular lines that are not straight up and down. It's not very perpendicular looking. So they can cross at a diagonal, but this angle right here, if we measured it, is going to be 90 degrees. Okay, so two things with this. If we have parallel lines, they are going to have the same slope. And different y-intercepts. With perpendicular lines, we're going to have negative reciprocal slopes. So what the negative reciprocal means, if we have something like 3/5, well then a perpendicular slope to that is going to be negative 5/3. So you flip your fraction and you flip your sign. Another example then, if we have like negative 1/3, that's negative, so our slope's going to be positive, and we would have 3/1, which is just 3. And if we just have, let's say like negative 7, then a perpendicular line, we have to put 1 over it, and that's negative, so our slope that's perpendicular will be positive. So that's how you find the slope of perpendicular lines. Okay, that brings us to a couple of examples. Parallel, perpendicular, parallel, parallel. Okay. So example 1 says, write the equation of a line that is parallel to the graph of y equals 2/3 x minus 4 and contains the point negative 6, 1 with both methods. So both methods are, point slope form was the first one, y minus y1 equals m times x minus x1, and then slope intercept form was our second method. Okay, so from our first line, so this y equals 2/3 x minus 4, if we're looking for a parallel slope, that means we're going to have the same slope. So the slope of our line is going to be 2/3. Okay, that is the only thing that you use from that line. So our new line has to pass through this point then, which is negative 6, 1. And then it becomes the method that we have been using for the past week or so, trying to figure out what the equation of our line is in slope-intercept form. So again, the only thing that you use from our first equation is the slope. We don't care about the y-intercept of that graph, because we're going to find a new y-intercept so that our line passes through the point negative 6, 1. All right, so y minus 1 equals 2/3, and then parentheses x minus negative 6, which would change it to plus 6. So in point slope form, we distribute first. Y minus 1 equals 2/3 x plus 12/3, which is 4. And then add 1 to that, and we get y equals 2/3 x plus 5. So there's method 1. Method 2, slope-intercept form. So in this case, we have 1 equals 2/3 times negative 6 plus b. So 2 times negative 6 is negative 12, divided by 3 is negative 4 plus b. And then to get that by itself, we have to add 4 to both sides of our equation, which means that b is 5. And our equation in slope-intercept form is y equals 2/3 x plus 5. So either method, we get the same exact answer. And we can also check that out graphically, see what it means. So our first equation was y equals 2/3 x minus 4. And our new equation is y equals 2/3 x plus 5. So you can see the red and the blue lines over there are parallel lines. And we want to know if our blue line passes through the correct point, which would be negative 6, 1. And if we take a look at our blue line, you can see it passes right through that point at negative 6, 1. Which means we can be 100% certain that we have the correct graph because we have parallel lines and our line passes through the point negative 6, 1. Alright, so that brings us to example 2. So example 2, we want a parallel line here. So I'm going to actually leave this one for you guys to do. So it's going to be exactly like example 1 that we just did. And then we'll go through example 3 together because we're looking at a perpendicular line in this case. Okay, so in this one, we want to write the equation of a line that's perpendicular to the graph of y equals negative 3 plus 2/3 x and contains the point negative 8, negative 3. It says use both methods, so here's point slope form, y minus y1 equals m times x minus x1. And here's slope intercept form, y equals mx plus b. So again, the only thing that we're going to use from our original equation is this slope. But remember, in this case, we're talking perpendicular. So that's where we have to have the negative reciprocal. So we'd have to flip that fraction, which is going to make it 3 over 2. And it's positive in the given equation, which means we need to make it negative for our perpendicular line. So our slope, negative 3/2. And again, that's the only thing that we use from our first line, because then we're figuring out what the y-intercept is, for it in order for the line to pass through the point -8, -3. So y plus 3 equals negative 3/2 parentheses x plus 8. So when we distribute this, we have y plus 3 equals negative 3/2 x, and then minus 12. So 24 divided by 2. And then we are subtracting 3 from both sides. So we get y equals negative 3/2 x minus 15. So there's using point slope form. And then slope intercept form, we have negative 3 equals negative 3/2 times negative 8 plus b. So negative 3 equals positive 12 plus b. So we need to subtract 12 from both sides to get b by itself, which means b is negative 15, which means that y is going to equal negative 3/2 x minus 15. And then just to kind of see what this looks like visually, we'll look at Desmos. So our original line is y equals negative 3 plus 2/3 x. So this is what that graph is going to look like. And the new line that we came up with is y equals negative 3/2 x minus 15. So you can see that these lines are parallel, especially if I make this screen square, zoom square, there we go. And we want to know if it actually passes through the proper point, which is -8, -3. And you can see that the black line, which is the line we came up with, actually does pass through that point at -8, -3. So we can be 100% certain that we have the correct line for this. And last but not least, that brings us to our last question. So write the equation of a line that is parallel. So this kind of jumps back to parallel lines. So with parallel lines, we're taking the same slope. So we're not doing a negative reciprocal because it doesn't ask for perpendicular. So our slope is going to be negative 4/5. And our point is going to be 5, -2. And in this case, we've done both methods enough, I think, on this. So pick whichever one you use and stick with it. We'll do point slope form since it's the first that we learned. And we have y minus -2, which is y plus 2, equals negative 4/5 of x, and then minus 5. So y plus 2 equals negative 4/5 x, and then negative 4/5 times 5 would be plus 4. And then to get y by itself, we have to subtract 2 from both sides, which means that y equals negative 4/5 x plus 2. And we could go ahead and check that and see with Desmos to make sure that we have parallel lines, that these two lines y equals 9 minus 4/5 x and y equals negative 4/5 x plus 2 to see that they're both parallel, number one, and that our point, or that our line passes through this point, 5, negative 2. All right, as always, if you have any questions, let me know.